Welcome to the Plant Engineering Webcast. Digitize to Modernize. Bring your electrical infrastructure into the 21st century, sponsored by Schneider Electric. I'm your moderator, Jack Smith, and I'm happy to join you today on behalf of Plant Engineering. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Type questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded and you will receive an email within a week with a link to the on-demand event. To download a certificate of completion, a PDF copy of the presentation, and other additional resources, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished presenter, Keith Negri. Keith Negri graduated with a degree in electrical engineering. He started his career with Westinghouse in 1982 in the Leadership Development Program, focusing on new equipment sales. He moved into Industrial Service Group at Schneider Electric in 1985 and has been in the power distribution service industry since. He has been both sales and operations manager for power distribution services with major various manufacturers. He is an industry expert, having worked for Westinghouse, ABB, Siemens, Eaton, and now Schneider Electric Square D Service. The past 15 years have been focused on extending the life and modernization of electrical distribution equipment using current technologies to improve performance of existing systems in various industries. Welcome today, Keith. The floor is all yours.
First, good afternoon, everyone. Again, as Jack indicated, I'm Keith Negri. Please bear with me. I'm not usually in front of this many people. But as Jack indicated, today's webinar will be covering the following learning objectives. What is at risk? Identifying potential problems with existing equipment. Provide overall benefits of digitizing existing legacy equipment. Number 2, breakers. What are the benefits of today's technologies? 3, relays, smart sensors, and meters. What are available solutions to help digitize? How does each device bring valuable, insightful data? Identify next steps to take to implement modernization solutions to help with digitizing your existing electrical equipment. What is the risk for your electrical equipment? Let's begin with the risk with the equipment. If we were to evaluate electrical equipment and categorize risk factors, we could group them into 4 categories. Risk of safety, uptime, efficiency, and compliance. Based on an article published by Electrical Contractor, it is estimated that 22% of all fires are related to overheating in electrical equipment. This occurs due to failures in insulation as they are exposed to corrosion and other hazardous environments and conditions that impact their integrity. Risk of uptime. Downtime can cause up to 40% of business downtime due to failures of electrical equipment that operate the lights and the business. Risk of efficiency. In addition, energy loss is the untold story in some facilities. Poor power quality and performance leads to high energy bills. Then last, risk of compliance. Need to meet the latest regulation and corporate sustainable goals. The importance of putting the risk compliance aspect, not having equipment up to the latest standards and regulations can have devastating impacts on the electrical equipment that can lead to other risks mentioned prior, putting workers at risk. Additional risks for facilities. Each facility also experiences risks such as unscheduled downtime, time spent to investigate failure when they occur, the loss of electrical equipment, high cost of repair, and high cost of investigation. And then most importantly, where there is no replacement, the possibility of loss of human life if an incident as they were to occur. We'll start off with breakers. Breakers, what are the benefits of today's technology? Well, with new low voltage breakers, higher fault current withstand without fuses, through door racking. And with through door racking, a lot of new manufacturers now have also remote racking for their breakers, which also puts the worker away from a risk of racking out breakers where an arc incident can occur. Closing and opening times have been reduced. This also helps with reduction in arc flash downstream of the breaker. Arc flash reduction features, energy reduction options, the introductions of energy reduction maintenance switches so that workers can work downstream of a breaker with less potential. Zone interlocking capabilities. These increase also the risk or lower the risk of arc flash downstream. Enhanced relay protection and metering. Digitization of the trip units with Bluetooth, communications capability, touch remote. These offer the ability to step away from the breaker while operating. And it also is a point where more information can be provided to the operator. Let's look at the new digital user experience. New breakers bring more data to users' fingertips. We can now configure breakers with a lot more options and make it easier for upgrading or even in new equipment. We can build in communication, mobile batteries to operate the trip units, EcoReach, which can add software and communications to the breaker. We can also do operating and maintenance. Using Bluetooth, we can monitor the trip units and monitor the condition of the breaker. Those are some added features now that weren't in older model breakers with older trip units that just covered the basics of tripping. We can also now, with communications, bring that data out of the trip units up to different softwares so that we can monitor, and we can also look at maintenance. We can monitor what's occurring within that trip unit and what's occurring within that breaker, and looking at times when we have to do additional maintenance to the equipment. And last is basically getting all that digital information up to a higher system so that operating and maintenance can look at more predictive possibilities and predict failures before they even occur, which will reduce many of the downtime incidents that do occur. Some of the other things, with addition of more relay capabilities within new breakers, there's more protection. Original breakers, if we all remember, old electromechanical trip devices were built into low voltage breakers. Now with new digital modules, we can add metering, we can add additional protection, and we can also add diagnostic to the trip systems. With new integrated relays capability, we can get class 1 power metering down to 1% accuracy. We have embedded diagnostics that the customers have more insight to how the breaker will perform or is performing, which would allow for better maintenance and planning for the future. Now, maintenance personnel can gather the usage of the breaker, what the trips are from a remote location, and monitor these instead of going up and having a full downtime and going up to the existing breaker to try to get information straight from the breaker. Now we can do it through a software or web access. Relay digitization. That's, many of us have already seen a lot of these old electromechanical relays out there. They're obsolete. The technology is obsolete. The range of protection is rather short for each particular relay, and there's a limited adjustment in that. Unit relays need, per protection function, the space. We used to have now for 50-51 protection, we'd have one relay per phase, including 3 on the door and then additional relays. Now we can bring it down to a digital relay, current state of the art, and protection. Newer relays incorporate more protection and more communication capabilities. New relays are also compliant to IEC 61850, which in many facilities is a protocol that is required. The relay enhancement protection, modernization, like for like functions of full advantage of technology. You can see in this picture the existing relay panel for a switchgear door. This happens to be an old Alice Chalmers, but you can see the mess of relays on that door and also the metering. You can see an old meter, old analog meter, a new digital meter. You can see old electromechanical relays at the bottom, and that door is just full of relays. With a new solid state, like for like, we can get the same protective functions of that existing, and now we're able to consolidate multiple relays on a door to one single device, saving some valuable space and other components to be integrated. So now we see that we've got that same 50-51, but now in one relay instead of 3 individual single-phase relays. We can also enhance that by adding more protection functions. Not only is it the like for the existing mechanical relays, but now we can add some additional protective functions and also communication. If you see in this next slide, this is kind of more of a electrical diagram of that. And we've gone from a simple LI protection now, and we move it on to a more multifunction protection. There we are, sorry, where we can add additional protection to that relay. And we can add protection to the downstream equipment. Some of the things that we can also add is new state-of-the-art relays can include light sensing for arc flash mitigation. We can either add a separate relay for arc flash light sensing, or some of the relays now have that built into the new solid-state relays. We also can add with some of this, as you can see, differential, which we can protect now a system and lower the arc flash incident downstream by having a differential protection relay scheme. One of the other offshoots of new modern relays is they can provide automatic transfer operation, can be now incorporated into new relay schemes. Most of these are basic auto throwover schemes, but they can now be added with new. So when upgrading to a new solid state relay, we can also add these features, which can add some additional protection and reliability to the system. We can also add thermal sensors, smart sensors. These sensors can look at equipment and look at the smart devices can be added to the electrical system for monitoring system conditions. I know a lot of us use thermographics at this point, infrared scanning to look at hotspots. These new devices or sensors can be embedded within the gear and look at hotspots throughout the gear and send digital communication back to a software to monitor. If we kind of compare this to a marathon runner to a substation, there are many similarities. In order to monitor the electrical equipment, we would supply thermal smart sensors to monitor the health of the equipment, such as your sensors within your Fitbit or your Apple can provide information back to you about your health. After that data can be collected with a SCADA, DCS, or other monitoring system, in addition to apps for greater insight to the electrical system's condition. We can also add other predictive equipment such as partial discharge or humidity sensors. These kind of give you a baseline of what's happening in your equipment, and this can be online monitoring where you can see this continuously, where some things like thermographics can only see when you're performing the thermographics, and it's not always seeing what's happening in the system and giving you that additional data. And also sometimes with external partial discharge testing, it's only monitoring when the testing is occurring. With embedded partial discharge, you can monitor all the time, and these two can be combined to add some additional predictive and preventative type items to your system for the maintenance and for the reliability of the system. Some of the benefits of infrared monitoring with thermal wireless sensors in lieu of thermographic IR window parts is it's more of a proactive maintenance. Thermal imaging sensors can let personnel recognize measurement variation and prioritize solutions that demand urgent responses. With online thermal sensors, you can see those heat variations at all times. You can also look at it and compare it to what's happening in your system. If there's a load increase or if something else, or if just the outside temperature is increasing, you can see what's happening there. Where again, thermographics using it with IR windows is only a temporary shot of what's happening in that system while you're taking those pictures. And it's not always as valuable as continuous online monitoring. Trending of temperature over time provides more insight and everything that you can gather with that data to make future decisions based on what you're seeing and what you're trending. Also, there's no shutdowns and less downtime. Sensors can be installed at a minimum downtime. And the other part about these sensors, they can be put into places where thermographic windows cannot be used, such as sometimes main bus and medium voltage switchgear, or in the low voltage bus and low voltage switchgear, where the windows can't penetrate some of the barriers and look at some of those joints that are occurring within those barriered off pieces of equipment or that bus. So these thermal sensors can be put into all kinds of different locations and then fed back through a system so that you can collect the data. So those are a nice addition to digital information and predictive preventative maintenance for future. And it's also safer for the employees because once these sensors are installed, the technicians no longer have to be close to operating equipment to take measurements. Even with thermographics and even with windows, it does put the employee in front of the equipment. So these are some great arc flash mitigation methods to keep employees safe and away from the equipment. Also, there would be a labor impact. You don't need somebody going around doing thermographic imaging anymore because the thermal sensors are online all the time. So due to that, and difficulty of access into some of the equipment, you no longer have to have somebody going around opening doors, looking into things, and again, being in an unsafe situation. Accessibilities. Thermal sensors, again, as I discussed earlier, can be installed within hard-to-reach areas and enclosures. And using a wireless sensor, this can be sent back, this information, and the sensors never have to be interacted with again after they've installed. And most of these sensors are without battery, so that they do not have to have a replacement or a battery replacement sometime in the future. So you don't have to get back into the equipment once these are installed. So basically, they could be improved ROI by being able to store the data in the cloud and readily accessible on computers or mobile devices. Kind of gives you knowledge into what's happening into your system. And again, these sensors can be looked at as individuals or they can be added to as a collective. And with that information, you can determine what's going on in your system. Again, whether it's a load variation or there is some kind of connection problem happening within your system. The importance of trending data and continuous monitoring. Okay, one of the things we talked about is with where we're going in the future and using some of this data to actually improve your reliability, improve your safety, and improve your uptime. Without 24/7 monitoring, the system puts at risk of failing when you least expect it. We all know Murphy's Law. It's going to happen on a Saturday or a Sunday when a failure and nobody's around, and somebody's got to be called in and downtime's increased. With the 24/7 monitoring, you can add additional maintenance practices that would be scheduled because you're seeing trending of something that occurs. So now you can schedule outage time to take care of that. The trending data allows the potential to be proactive and schedule that maintenance when needed using insights from the different smart devices. Thermal sensors allow communication with SCADA or power monitoring systems and can send alarms when attention is needed. So we can set the parameters, and when we see a heat rise, we can actually send an alarm out so somebody can be reactive or proactive to a situation instead of reactive to a situation. And then there are cloud-enabled services, such as from Schneider, that can look at all of these different devices and give expert opinion on what's going on with the system. Again, like I indicated before, just because the temperature is rising doesn't mean there's something wrong with the system. There could be a rise in the load also. And we need to make those comparisons of the rise in the load and the rise in the temperature to see if it's an issue going on with a connection or if it's just a normal operational issue. And then reduce number of infrascans of equipment through infrared windows, and also the cost of adding windows. Now you can reduce that cost or not have to add windows because you can use thermal sensors to come back to the system. With system monitoring and alarming, sufficient time will be given to fix any issues before there is an extensive damage at that time. One of the other things is power monitoring and digitizing power monitoring. As we walk through some facilities and older facilities, we can see that there's old digital or old analog meters out there, all kinds of places that were put in many, many years ago. And those really don't give you a good idea of what's going on in the system. They can only tell you that you've got voltage and amps and how many amps might be occurring. All right, they're very limited in their availability of information, limited in features, and require regular testing and calibration. And we've seen these meters out there all the way even to electromechanical watt-hour meters. Now with new power monitoring and with digital power meters and current state-of-the-art, we can look at a lot more of the system and get a lot more information. We can manage decisions made using data and analytics from one power meter. The typical power meter may now allow for power quality analysis, data analysis and visualization, communications back to, again, a software system, and real-time monitoring and alarming. And again, this is just another device that adds to the system so that now you can take all this digital information and make comparisons of your system within the software. They can bring you, whether you have a power quality issue, whether you have a load issue, whether you have a demand issue, and all of these items added together with the other information that we're gathering from digital devices helps us make better decisions on how we run our processes, how we run our system, and what our loads and energy look like. Some of the benefits of digitization using meters is identify inefficiencies, able to get insight to your subsystems. You can see if there's power factor problems, if there's power quality problems, if there's harmonic problems. And these are going to be some items that can save you money. Excuse me. Once you have identified the inefficiencies in your power consumption, you can take the necessary steps to design and implement energy savings programs to help you save money. It'll also increase profit margin. With a reliable energy management system, you can spend less and make more. And again, who doesn't want to make more? Decrease downtime. Our monitoring systems can send you alerts when something is not right, helping you cut back on your costly downtime or even eliminate it altogether. These are just some of the benefits. We can also look at what's happening outside of the system, what kind of energy you're getting in from your utility source, and where we're at with that. And seeing, sometimes it's the utility that's causing problems within the systems. We can identify those problems and report back to the utility. Not always can we do something about them, but we can also look at what kind of power is coming into our facility so that we can manage that. And if we have to put in, either capacitors, or if we have to put in other devices that help us to smooth out the harmonics and other issues that might be coming down the line. Often there's facilities maybe next door that are providing bad feedback into the system and causing, sags and swells within the system as they turn on equipment, which affects our systems. So with power monitoring, we can look at that and see what's happening and get a better clue of what our system looks like, and also what we can do to help improve that system so that we have a much more reliable and safe system at that point. So these are some of the benefits of using meters to get digital information back to our system. Some of the steps to take to implement modernization. When we're looking at implementing thermal sensors, protective relay, breaker, and power meters, there are 5 steps that can help with this process. The first step is to take time to do a proper assessment. Identify critical assets to be upgraded. Get all the installation information, equipment, and IT. Those are always important because we have to look at what should be upgraded, what needs to be upgraded, or even in some cases, what needs to be replaced. Okay, we also need to understand what the critical points that are needed to be monitored. Oftentimes, companies may provide assessment services or pre-engineering solutions for this. Next is to take a look at other connected equipment that may also benefit from being connected. Knowing breaker and relay information can also be valuable data along with thermal readings to truly gain these insights needed to take action. With new sensors and protective relays, breaker and power metering implemented into the equipment, we can gather a lot more information as to what's going on with our system. With much of the old equipment, there's really not much information that we can gather, how the system's functioning, what its health is, what areas of maintenance, and again, what items really need to be replaced. That's why a full evaluation needs to be done of the existing equipment and see what condition that equipment is in, what needs to be upgraded, and also what needs to be monitored. The next step is the communication configuration. After the assessment, another equipment review involves connecting all the devices. It is better to have the thermal sensors to be part of an overall monitor than it is to have them stand alone. So a lot of times when we start off with a system and we put in thermal sensors, then we can monitor those, but again, that information doesn't always give us the right answers. That's why when we connect other devices such as protective relays, such as power monitoring, we can get a better picture of what's happening in the system. So we want to add those all together and take all that information and then come up with a conclusion with the information we're getting from all the different devices. And then the step 4 is an internet connection. Connect the system to the cloud platform. We have software and we have platforms out there that we can connect this, and various people then can look at the system and look at the condition of the system. And then step 5 is the predictive, and that's to configure a web platform such as Schneider's EcoStruxure Asset Advisor. And again, that is a web-based service that can look at that, and using our engineers and using our people, we can take a look at and compare all the different data that's coming in and help you make a better conclusion of what's happening with your system, instead of taking each individual device and trying to come up with something that might be telling us a different story. So that's one of the cloud services that is out there to do that. The 5-step roadmap for digitization, and you're going to hear that word digitization quite a bit because a lot of new systems. You see it very heavily in the cloud-based providers. Our new data centers and that are gathering. They gather lots of information to always monitor their systems because downtime is very costly, and predictive maintenance now is the way to go instead of just preventative maintenance. Now if we can predict that there's a failure, we can get ahead of the game. So with digitization, we can look at all these different items and start off and build a roadmap for it. And again, we need to look at the feasibility. We need to look at doing a feasibility study to look at different concepts and the different goals of what you want to look at. And typical deliveries of preliminary studies can move us on to the next step of actually doing a front-end engineering feed study at that point. Though the 5 steps you are able to better understand and lay out a plan on how to set forth a path for digitization. And the first 3 steps with the initial goal is to work with an engineering group that can become the primary design agent or a trusted advisor and lead in these phases and drive the others. They would engage as early as possible, providing a starting point and a level of commitment. And this gets you going so that you know where you want to be and get this a design together so that you can see what the cost and what the implementation of this cost is going to be into your system. Okay, so basically using these 5-step roadmap for digitizing your installation is very helpful to, instead of just being reactive and start replacing this piece of equipment and adding a meter here or a meter there. A better plan is to go through this process and then do it as an installation or do it as a progressive series, but you at least know what steps you want to take and what equipment you need to prioritize before you get to the end, and then you start commissioning that equipment. Kind of one example we're going to kind of use here is just a small substation. Okay, now that we've learned about smart sensors and other digital devices, I'd like to take a moment just to look at a quick example here on where monitoring and enhanced protection would and could be implemented within a facility's electrical equipment. So basically, to summarize, electrical equipment experiences heat over time due to several factors as overloading, loosening of connections, or environmental conditions. There are many solutions to monitor temperature to prevent arc flash incidents that can be detrimental to a facility. With thermal smart sensors and improved protection, you're able to continuously monitor your equipment and gain valuable insight to establish a proactive approach versus being reactive. This could save you money, time, and lives. So looking at this example, we look at the substation. We're going to add ambient temperature. We're going to add ambient humidity sensors, and then others such as partial discharge. So in like a low voltage, a medium voltage, and busway, we can add these sensors throughout the equipment. Okay, and then if we upgrade the breaker, we can also look at power monitoring through a low voltage breaker, or we can add a meter or a relay. With low voltage, again, with some of the new trip units that are out there, you know, we can also add other additional protective devices other than just long time, short time, instantaneous, and ground. We can do phase loss. We can do differential now with some of the added on digital modules that can be provided with new breakers and new low voltage equipment. On the medium voltage side, we can upgrade that by adding new protective relays, as we indicated before, with like replacing the old electromechanical relays on a door with a new solid state relay. We can also look at adding power monitoring, and we can also replace that old air magnetic breaker with a new vacuum replacement breaker, and upgrading the safety of that system, both from a protective situation and from an arc flash situation. And again, we've got other devices within the low voltage breaker that can actually send information back to a system to see what's going on in the system. So we can upgrade the low voltage, we can upgrade the medium voltage, we can add, again, temperature sensors to all of these devices so that we can monitor the heat that's occurring and looking for failures. We can also look at transformers. We can use the transformer, either upgrade the transformer relay. There's a lot of new relays out there. We can look at the temperature. We can add that into the software, the temperature sensing within the transformers that might already be there. Or we can add smart sensors to the transformer. Many dry type and liquid fills have temperature sensors that either monitor for a dry type, the winding temperature. We can add that into the system, or for a liquid filled, either the oil temperature and or the winding temperature. So those are different ways to do that. And then with all of these devices we're adding to the system, we can now bring them all up to the cloud for additional monitoring by either the plant engineer, the plant maintenance, or an outside concern that will help make decisions for the future on how to maintain that equipment and to keep it up and running and reliable and safe. And kind of an example on a low voltage architect, when you upgrade to a new breaker, now you have the ability for a mobile app. You have a Bluetooth device that you can look at on your cell phone, or else you can bring it up through a system through various I/O modules. But as you can see in this example, you can add the power meter to the software. You can add other devices to the software and connect them all together to give you a better picture of what's happening in the entire system. So again, now we can take all that digital information, bring it up to a software and monitor it and look at it from all kinds of different aspects, from thermal, from overload to power quality and what's happening. And again, with those Bluetooth devices, we can also look at it, like I said, right on our smartphone, or get alerts to what's happening to that system. So we can get alarms and alerts so we know ahead of time or when something happening right away. So those are some of the examples that we can use while digitizing our equipment and getting it up there. Well, where today's equipment or older equipment does not have these capabilities and cannot provide you that information. And again, a lot of our failures, unfortunately, Murphy's Law indicates they're going to happen at the wrong time in the wrong place and right in the middle of a long production process. So kind of in summary on this, when we look at the entire system, we can bring the electrical system up to the 21st century without replacing all the equipment. We can add new breakers. We can add new relaying. We can add new power monitoring. Now we can add thermal sensors and humidity sensors within the equipment to look at all aspects of the equipment so that we can get increased safety for operators and people working around the equipment, as operation and monitoring of the switchgear can be done from a safe distance. And again, we looked at now with the low voltage devices, we can actually use our cell phones to open and close those breakers from a distance so that we can put our people into a safe spot for opening and closing low voltage breakers where there's a lot of incidents of arc flash that occur at that level. We can improve the reliability of our equipment by getting more information. We can look at doing more predictive type work than we could before. Most of what our past applications was doing preventative type work and hoping that we found everything. Now with a lot of these new digital devices and smarter relays, we can actually see what's going on in the equipment all the time, online, and at a regular interval, we can go in and fix and repair items that we are seeing failing before they fail. So that gives us improved uptime and improved reliability. And also compliance to the latest standards. Standards have changed over the years. And now with some of these new and retrofit equipment and modernizing of equipment, we can meet some of the new standards that exist. I mean, one of the new standards is some type of energy reduction at 1200 amps and above. We can now meet those with with upgrading and modernizing the existing equipment without replacing it. We can also look at the power quality and insight to energy savings. This is one of the areas that we see a lot of people with either peak demand problems or poor power factor problems, or even harmonic issues where we can help out with power quality and manage those items and reduce them for cost savings, because harmonics increase a lot of heating that goes on in systems, and it also damages other pieces of equipment. So we can look at that through power quality and analytics of that. Predictive analysis through cloud services. Again, there are services such as Schneider provides that can look at all of this information and all this data that's being collected now by these devices and determine and help determine what's going on in the system, whether it could be a transformer that's failing, could be a breaker failing, it could be bus failing. We need to look at all of the information provided to get a better, clear picture of what's happening in that system. And again, with older equipment, you can't gather that information because it's not available to you. And you just have to sometimes go on hope and testing and maintenance and hope that gets you through and that you can catch some of these items before they fail. With now, again, with new digital equipment and gathering that information, we can do much more predictive and catch things before they actually occur. And, we have examples of that within our own cloud-based systems where we have caught failures before they were catastrophic, and we're able to protect or replace equipment before we had long downtimes, or get ready to replace equipment before there was a major failure. Pretty much coming to the end here, and these are some of the references that were used for this presentation. So you can see that there was different areas that we used for this. And so basically, that's pretty much the end of my presentation. So I'll go ahead and turn it back over to our moderator.
Great presentation, Keith, and a lot of important information in there. And now Keith Negri will answer your questions. And so type your questions for Keith in the Ask a Question box on your screen, and we'll get to as many of your questions as time allows. Questions that we don't get to today will be posted online with the archived version of the webcast. Remember to download a certificate of completion or a copy of the presentation or other resources. Use the Event Resources tab on the left side of your screen. So let's get to these questions. First question, what is the useful life of electrical gear? And I'm assuming switchgear, or I guess maybe it could mean breakers as well. So.
Sure. Basically, in manufacturing, most of the manufacturers look at a design life of about 20 years for their equipment. There's many different factors that can affect that. Environment, maintenance, condition of the atmosphere. Some places out west are much drier. Some places on the east or on the coast see a lot of humidity along with salt that can do damage to the equipment. I personally grew up in the Midwest where there's a lot of humidity, so a lot of the equipment is exposed to high humidity, which could cause rusting and that. Where out in the West where it's very dry, we don't see that. Also, again, it's the environment. You walk into a data center and the equipment there is very pristine. There's clean rooms. There's ventilation to take care of that. There's other places that where the equipment is, again, exposed to harsher environments, depending, if you walk into a cement plant. There's not much they can do about it, but there's a lot of cement dust that flies around. And that cement dust can get in the equipment. It can affect the operations of breakers. So the lifespan of equipment is really dependent on the condition that it's working under and how much load it's occurring. So, that would have to be evaluated by professionals to take a look at the equipment, see where it's at in its life cycle and what the environment and conditions are. So hopefully that answered that question.
Well, not only did it answer that question, but it answered the following question. So I'm going to modify the following question a little bit to say, what would there be a difference between, let's say, for example, the lifespan of switchgear and lifespan of, let's say, a motor control center or circuit breaker? Or would they, was it a one-size-fits-all lifespan?
Well, I mean, that's a good question. And, a breaker's, the lifespan is often less than it is of the equipment that it's in. Breakers are a mechanical device that operate. They're exposed to, again, conditions of the environment. And breakers also have pivot points because they are a mechanical device. Those pivot points are lubricated. That lubrication over time fails, or under conditions the trip units fail due to the fact that, from heat and from energy flow through the system. Often what we see is some of the breakers' lifespan is less than the equipment that it's packaged in. So that's why modernization can be very beneficial, because sometimes the sheet steel and the bus and the insulation and support are in fairly good shape, and sometimes we can do some re-insulation in that, but often the breakers are worn out over time from operation and use. And also with some of the new technology, those would be the first to be upgraded. So it is you're correct on that. There are different lifespans of different parts of that equipment, and often, again, it's the breaker that fails sooner than the rest of the equipment, or the old electromechanical device, such as the old electromechanical relay, or within the breaker, a low voltage breaker, the trip unit itself, because it might be an old electromechanical trip unit. So yes, that's a very good question. There are different parts of it. And again, that's why modernization is an important part of this, because some of that existing housing can be reused and is in very good condition, and it can be upgraded, or there could be some additional bus bracing added to it to bring it up to today's standards, and then the breakers can be replaced, the relays can be replaced, or the power monitoring can be replaced. And you can keep the old system, you can keep the old cabling, and don't have to do any construction to replace that.
All right. Answer. Yeah, good answer. What is the typical return on investment for replacing legacy electrical equipment with modern equipment, including sensors and meters?
Well, that one's a tough one to answer also, because it's under different applications of the equipment. If the equipment's under a harsh environment, the upgrading of that equipment or replacing of that equipment has a high ROI because of downtime and production loss. Again, we see, I'm going to use examples of a data center where downtime is very expensive and very critical. To lose any part of that equipment is going to be very costly. So they're doing a lot of upgrading and upgrading that equipment to bring it up to today's standards, and also to make sure it is reliable at that point. So reliability is a big factor in replacing that equipment, and what is the cost of downtime. And that's a strong factor in your ROI calculation. Also the fact that how long is this equipment going to continue to work? How long is production at this facility going to occur? So those are some of the factors that you have to put into ROI in replacing or modernizing. I always look at it this way: if a company has the time and the money, the downtime capability, a lot of time it's just better to replace everything. But if downtime and construction costs are a large factor, that's where upgrading the equipment with some of these new sensors and meters are of value. And again, as we talked about power quality meters, there's some things, if you upgrade those, you might have some instant energy savings or demand saving that have a quick return on ROI. Some of the older equipment, if it's starting to fail and you have continuous short outages and downtimes that cost you production, then the ROI could be that much quicker as far as the payback for replacing these items or upgrading them. So it's going to have to be looked at on somewhat of each individual case, and all those factors have to be added in to determine a good ROI on that.
Well, I think you did very well on answering that one, even though it was kind of a tough one.
Yeah.
So, next question: does Schneider have a team that can survey switchgear for upgrades? There are so many different manufacturers, including custom, that would require bus reconfiguration.
Yes, we do. We have a program in place that goes out and with our engineers, and they analyze the equipment. They take down equipment information. They look at the equipment. They give you basically a result of that analyzing, looking at cables, looking at breakers, looking at equipment, looking at the life, the age, the vintage of that equipment, and can give you a better idea. And a report comes back indicating what the needs are and what the priorities are. And they look at both modernization and performance of that equipment and the safety of that equipment. All those things are factored in to when they look at it and finish their report. Because, I mean, there's safety factors now involved with old equipment to new equipment. New equipment has a lot more safety built into it. So yes, we have a group that goes out and does the analyzing and looks at the life expectancy of that gear and can give you a report back what we feel that life expectancy of that gear is and what condition it's in and what should be replaced and what shouldn't be replaced. Because not always does everything have to be replaced, or upgraded. Sometimes it's fine where it's at, and we'll let you know that too.
Oh, just to
So
upgrade everything, right?
I'd like to say that, but I can't be, I've got to be honest here. Not everything needs to be upgraded. Not everything needs to be replaced, or not everything needs to be modernized. And, so we like to look at it and give you a report back telling you what we see as the critical items and, what needs, again, what does need to be replaced or what doesn't need to be replaced, or, somewhere in between. So hopefully that answers that question.
It sounded good to me. So I'll give you another one. It's switching gears. Yeah, switching gears here.
Okay.
Words. Well, what is the standard that specifies that energy reduction is required for 1200 amps and above?
That's in the new codes. That came out in the new codes, and in the 2020 codes, that equipment of that has to have some types of energy reduction. The Schneider interpretation is that when we're upgrading equipment or modernizing equipment, that also applies. Not everybody agrees with that at the moment, but on new equipment, and the new code does call for that in 1200 amp and above. So code does require that on new equipment. But again, on existing equipment where we're modernizing it, Schneider does recognize that as that. But again, some people and some customers don't recognize it. They look at it as it's existing equipment. It still fits under the existing code that equipment was built. So we provide you the option when we do modernization to add energy reduction at 1200 amp and above or not. But we'll always provide you that option.
You mentioned thermal monitors feeding back to the cloud.
Yes.
Or such. Do infrared sensors also provide simultaneous feedback to give redundancy?
Depends on the type of sensor. Most of the infrared sensors are momentary, and they're only taking a picture at that time. That's why we look at thermal sensors, which are connected right to that bus or connection point, so that it actually is connected there and gives you continuous online monitoring. I would have to look into, to be honest with you, I don't have a full answer for that. I'd have to look into some of these infrared devices. But again, if we're using Windows and an infrared camera, it's only that moment that camera is taking a picture, that it can bring any information up to, either record that information or bring it up to some kind of cloud-based system. But with online thermal sensors embedded into the equipment, that is continuous online, and all that data can either brought up to a local software or it can be brought up to the cloud to be monitored and viewed from other places. So hopefully that answered that one, or at the best I could on that one.
Yep, sounded good to me. Can you
Okay.
talk about refurbishing used circuit breakers?
that is the new buzzword for 2020, because the new code came out for 2020, the NEC code, reviewing and regarding reconditioning of equipment. And those codes came out, and there's still a lot of conversation, to be honest with you, about interpretation of that new code and analyzing it. The real reason for that new code for reconditioning breakers was because of safety issues. And we want to make sure that in that reconditioning process that it's done to the best of ability and also to the standards today. So I'm gonna have to say right now that's a kind of a question that's hard to answer because of everybody's different interpretation of the new NEC code, and we're waiting for some of the committees who are still reviewing that to come out with a conclusion as to what the processes are going to be and what the standards are going to be for reconditioning, if there's going to be reconditioning, because in part of that code there's talk about only reconditioning of switchgear type breakers in lieu of molded case breakers, and the molded case not being part of that reconditioning, that they have to be replaced and upgraded. But again, those standards have not, or the committees have not fully formed all those standards out of the 2020. But again, most of that, the upgrades in the 2020 code are for safety standards to make sure that everybody does a quality job in upgrading and reconditioning of equipment. So I kind of danced around that one because again, we don't, you know, Schneider's on the committees. There's several manufacturers on the committees. There's several rebuild facilities that are on the committees coming up with these standards to meet the NEC 2020, and that's really all about reconditioning of equipment and where that falls, especially with NFPA 70E.
Right.
Okay, so there's not a real answer yet, but there's committees working on it, and again, that's all about improving safety and making sure those reconditioning processes are done properly and to the manufacturer standards, and that equipment comes out safe.
We have time for one more question, and
okay.
It's please talk about arc flash resistant gear and 100% rated versus 80% rated breaker ratings.
Okay. The arc flash resistant gear, most of arc flash resistant gear right now is developed in the medium voltage and low voltage switchgear standards. And those breakers are 100% rated breakers, so it's really not going to affect those. As we get down into switchboards and panel boards, it shouldn't change what that breaker, whether it was an 80% rated breaker or a 100% rated breaker. I don't want to say something incorrect, so that's one I will have to take offline and get a better answer for. But I don't believe it affects the rating of that breaker if it's in an arc flash or arc resistant gear.
So you rate the gear, not necessarily the individual components.
Yes, sir.
Okay, that's the way I interpret it, but you're the engineer.
Exactly, but again, I don't want to say anything incorrect, so I will have to take that one offline and get a better answer for that.
Thanks for the great questions and the excellent answers, and thanks again to our great speaker, Keith Negri, for sharing his time and his expertise. I'd also like to extend a special thank you to our sponsor, Schneider Electric, for sponsoring today's event. Now that we're just about done, we want to hear how we did. The exit survey will pop up on your screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. Finally, on behalf of Plant Engineering, and Schneider Electric, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.